Okay, I wanted to continue a little bit with the search interface lecture. And so, what I wanted to do is provide a way, like this kind of shows, for you to enter some keywords to search by. And so, kind of glancing at the app that I've been doing during lectures is this dog walker database and having different walkers. So I've got a few pieces of sample data in there, of which I need more. I want more. I want to be able to, filter these records. Right now there's only 5 records, and so, what I wanted to do is kind of delete these and get some new, what you would call seed data, to be able to search through. And so as I delete these here, a website for kind of generating seed data is called Mockaroo. So then I'm going to go to Mockaroo here, and I'm going to basically generate a bunch of dummy data. And so when I go to Mockaroo for the first time, this is kind of some examples of some seed data that you can have an ID column, first name, last name, email, gender, IP address, and your data types are in this column. So the field name and then the data types. And then what we'll do is we'll generate data accordingly. So I don't really need an ID, so I'm going to get rid of the ID. I'm going to let Mongo generate that. First name, last name, email's all good stuff, gender's fine. I'm going to get rid of IP address, and there's all sorts of data that you could put in here. And so maybe like URL is what I'm thinking, and URL. And just a little bit more, and maybe we'll create 100 instead of 1,000. 100 records in a JSON format inside of an array. And so you can kind of, again, change the data that you want to seed. And if I preview this, it gives me a lot of data. And what I might do is search by URL. And so if I just kind of search for the word Google, you can see the Google's in some email addresses, 5 different records, email, it's in one URL, it's in a couple of URLs, and it's in a couple of emails. And so if we're allowing a user to search by keyword, allowing something like a Google or whatever, Alibaba, whatever they want to search for, Cloudflare, whatever URL they want to search for, that you could, that could be the purpose of our search, allowing a user to kind of type in their own domain that they want to search by. And then let's do age as well. So let's add another field of age. Let's just do number between 1 and 100. So there we go, age between 1 and 100. Now if we preview that, that'll give us the person's age. And hit Control A there, that doesn't work. Go down here and copy that. Now, well, I'll just kind of keep that there, because now what I need to do is I need to run an insert many command in Mongo to enter that into the walkers collection. So let's boot up a shell. And I need to connect in. So let's go here. Let's go here. And connect through shell. Paste that in. So all this is a normal command prompt. So I just went CMD, paste in my connection string, enter my password, see if I've got that up. Copy, paste. Okay, show DBs, use dog walker DB. Show collections. Okay, DB walkers, insert many. And copy. Now again, the outermost is those arrays. So let's paste. Paste anyways. Oop, didn't like that. Didn't like that many times. Nope. Let's just insert one. Insert one. Not having a lot of luck at the command prompt. There's another way of doing it. Let's do insert document. Try. I've done it this way before as well. Again, copy. There we go. So what I did was I clicked on Insert Document, and then I clicked on the JSON, and then I pasted all my sample data in that way. And now we have plenty of records to filter. So we got 100 total documents. And Grant, did that work for you?
Yes.
Okay, cool. Yeah, it's the way it's pasting in at the command prompt isn't letting me kind of finish the command. It just wants to execute right away. So it's not being friendly. But solved it this way. Okay. Next up, let's open up the Dog Walker app. Make sure that it's most current version. Cool. Open up Postman. Looks like port 5000. Port 5000. List our dog walkers. Gotta run it. Booted up on port 5000, database pinged. And now we are selecting all of our dog walkers. So we've got a new bunch of sample data, seed data in the database. We're able to read out of that database from our application. And now we go about building an aggregate pipeline. So let's start in the walkers.js, and this is our list. And I want to show, so far we've been getting information really out of two places, right? In Postman, we've been sending data across in the URL. What was called a parameter variable, right? So we've been sending the data across here. We've also been sending data across in the body of the HTTP header. And so we've been sending data across those two ways, right? And again, in the URL and in the body. You can also send data across in what's called a query string. And so notice here, like if I set a variable called keywords, and let's just say I wanted to, google.com, right? You might have seen this question mark up in URLs before, and that's called a query string, anything that comes after a question mark. And they kind of follow the convention of variable equals value. And then maybe I would set min age to 5. And so you can kind of see here, these are two variables that are stored in what's called a query string, anything after the question mark. And this is a third way that we're going to send data from the client to the server across is in a query string. And so we'll be using that to help us with our search interface. And so maybe let's just put the keywords google.com in a query string. And really that's not going to do anything for us, right? But what I can do now is in my list route, instead of just saying that, list route hit, I'll say the keywords sent in the query string are, and then this becomes rec.query. Dot keywords. That should be a query object, and then the keywords property. So let's kind of hit that. And then it says the keywords sent in the query string are google.com, right? So the variable keywords holds the value google.com. So rec.query is the object, just like rec.body, that's now rec.query. And you can kind of see, if I just get rid of the keywords and just throw that back in there, you could see that's just an object. So you need to basically say, hey, I've got keywords, and that's where you get the value. Okay, so now that we have keywords, again, back to the lecture here, what we're trying to do is allow users enter keywords for their search. So when I'm saying keywords, when we actually build the front end, that's what the users are going to type into the search box, right? And we're going to send those keywords to the back end in a query string, right? Which again kind of is in the URL after this question mark. Is that making sense, Grant?
Yes.
All right. So what? So now we got to get into this aggregation pipeline that we just kind of covered. So let's write some of that. So we do have instead of returning all walkers, right? We're not going to be getting all the walkers right now, so I'm actually just going to kind of comment that out and comment that out because we're not returning all the walkers now. We'll do a little object destructuring, right? We'll say let keywords equals rec.query. Okay, so this will make a variable called keywords. If that property exists, right? So otherwise, that variable won't be created. So what's our first stage? Our first stage is the match stage, right? Which means, we're filtering. This is our filter. Match stage equals where clause in SQL, aka our filter. So we'll make a variable const. Now, this basically says when you're creating an empty object, right, that there's no filter, right? So by default, we're going to get all records. And we say, hey, if there are keywords, right, which means the keywords are read from the query. If there are keywords, we're going to do a text search. Now, I didn't talk about a text search yet, so I need to kind of explain the way this works, right? So the $ text operator allows you to search for a string of text. And so it actually takes 4 options. The first one is the most simple. So normally, on a find, you would specify the field that you're looking for. But now, using this text operator, we're going to say, hey, we're looking for text. And the first option that we're sending is the string we're looking for. So we're looking for the string matrix inside of db.movies. Now, in order for this to work, in order for this text search to work, you have to have a text index created. So if I kind of pull from this code a little bit, let me go into my command prompt and let me just kind of use this as a demonstration out of the lecture. So I want to connect into Mongo. So let me go database. Let me connect via the shell. Connect back in. Pull my password back up. And let me show DBs, use sample mflix. Okay, so I'm in mflix. And if I were to just run this query, you're going to get an error message as the next, this is the error message that you would expect to get because we haven't set up now I got it back. Presumably that's because I set this up already. Grant, did you get the error message?
I haven't gotten there quite yet.
Okay.
Sorry, I disconnected from Netflix.
No, that's no problem. Just to show you that I've done this before. If I go into my collections and I go to mflix and movies indexes, you could see that there's my text index right here.
Right.
And I can delete that, drop that index. Now this is the one on ID. Let me drop that. Okay. So now if I go back, run that same query, there you go. Text index required for the text query. So that's what I would expect out of the box, is that you cannot do a text search without adding this, without adding this index. Now, here, very simply, to create an index on all of the columns or all the properties, you can run this command right here, db movies create index. This is kind of a wild card saying, hey, on all of the columns or all the properties, this is a text index, and call it full text. So if I copy that line of code and paste it and hit enter, might take a second here, and eventually it responds with, hey, I created an index called full text. Go back over here, and now if I refresh my movies collection, I go indexes, there is my full text index that I just created. Okay, so kind of out of the box, you have to run that command to enable the text search. Otherwise, it's not going to work. And to kind of go back here to the command I ran, if I just do, now the second, this is the search, right? We're saying, hey, $text, $search for the word matrix. But then the second argument says, hey, give me back the title and not the ID. I'm going to get rid of that second argument. Just run it like that. And, well, it gives us back a lot of more information. I guess the point is, if I kind of clear the screen, right, so here's the first command that I ran. It just gives me back the title. But, here, you got the matrix reloaded, animatrix, matrix revolutions, but, the title commando, well, there's no, obviously matrix is not in that title. However, it is looking through all the fields, right? So maybe in the description, the word matrix came back, right? So if you didn't want to search all of the fields like it's doing here, you could say, okay, well, I just want to create a search index on the title field, the plot field, and the full plot, right? So if you want to specify more specific fields to search, you can do that as well. You just got to create an index on those 3 columns. But, for our purposes, this is going to work, right? We're going to create an index, okay? Now, back to what we're doing, okay? We have to create a text index the same way on our database, okay? So, let me show DB, use Dogwalker DB. Now this becomes DB dot, the name of our collection is Walkers. DB.walkers create index on all the columns called full text. Okay, much smaller database, created much faster. And if I go to my indexes, okay, we have a full text index. That should allow us to accept keywords from the front end to search by. Okay. Very good. Back to the code. Grant, you keeping up?
Yes, I think so.
Cool. Okay, now we're going to use Postman. We're going to send across some keywords. We're going to read those keywords from the query object. And if those keywords exist, well, by default, we don't filter anything. We have an empty match. If the keywords exist, we're going to say the match object dot $text equals, very similar to what we just wrote, $search keywords. So if I kind of go back to the query that we wrote over here, $text, $search, and then the keyword was matrix, right? Compared to the match object, $text equals search keywords. And then I want to keep my, start simple, and let's go ahead and connect and make our cursor const cursor DB collection walkers. I believe that's what it's called. DB collection walkers. Aggregate. I skipped over my pipeline. Const pipeline equals array first object $match is the match object that we just created. So we created this match object. If the keywords exist, we add them, and then we add that to our first stage in our pipeline. Pass the pipeline to an aggregate function, hitting the walkers collection, and let's so this kind of builds the query, executes the query, and sends it back. Res JSON walkers. Now by default, if I uncheck keywords, let's see what crashed. Const DB await connect. So connect right here. Yeah, we have to await connect. Back to my list. There we go. We've done that 15 times. Await the cursor now. Let's try again. Okay, so this is no filter, right? That just basically started off saying, hey, there's no match because there's no keywords. We don't update this, and our pipeline doesn't filter anything. Therefore, give us back all the data. However, if I go back here and I say keywords google.com, now we can see a lot different data set coming back. This is the URL Google. Now, and close that. Don't save. Let's uncheck that. So sent back is 84K. If I filter, 74K. However, that's very obviously Google. I'm confused. A little bit. It is finding google.com. Let me do something here. Keywords are Google. Match. So just in doing a little bit of troubleshooting, I don't think anything's wrong. I just think it's a little hard to see what's happening. And so here's what I think might be happening. If I run this query, right? So this is DV Walkers .find text search, and let's just search for Google.com, and I want to return just the URL. And so we're getting all that same data back. And then you could see type it for more. So let's run that query again. If you change it from google.com to just the word Google, you get a lot less results back. And in that, you can see the word Google. Except for what comes after USA.gov, just looks like junk. I don't see the word Google. So there's Google, there's Google, there's Google. Let's search for the word Army instead, right? So there's army.mil, there's army.mil. Yeah, that's interesting. So keep in mind, so if I get rid of just that second query, that's Army, and that one had the email Army. So the word Google's in the record somewhere. I'm just not seeing it in the document. So it's working as intended. It's just kind of hard to parse through the data because there's so much of it. But very clearly, if I go back to Postman and I search the word Google instead of google.com, now you see I get 6K of records back. And somewhere in here, there's a count of the number of records. Postman. One, two, three, four, five, six, seven. About 7 records. So it's working. So that's the first stage. Let's pull this back over. let's do a minimum age and a max age. So now we're going to filter by, let's say, if min age and there's a max age. Let's first parse whatever is there into an int. It'll probably be coming across as a string, right? Max age, parse int, max age. We'll set the age field greater than or equal to min age, less than or equal to max age. So if we send over a min and a max, we say, hey, it's greater than or equal to the min, less than or equal to the max. And that's all done. That's all done in match. So we just modified our match object to include an age filter. The age filter is greater than the min and less than the max. So now min age is 5, max age is 30. So now age should be between 5 and 30. You can see our records are much more reduced. So doing a text search, min and max. Now there's no guarantee that there's both, right? So we could say else if there's not both, maybe there's just min age. And then we would set match.age equal to greater than or equal to min age. Else if max age match.age. Okay, so then now maybe we just set them max depending on our data. So if we set the min back to like 10, that should get rid of Teresa, right? So 10. There you go. If you get rid of the min age, that should bring Teresa back. There's Teresa, she was brought back. Right, so that's minimum and maximum age. Let's go back to our sample. Maybe we only want males or females, or sample data set also has non-binary as an option. So let's do a gender filter. So comma gender, and if gender match dot gender equals, and this is just a EQ gender. So now we can go into here, say gender and males only. And this is our only record matching all of those. So we got 3 records, female, female, male, that are matching all of those. If you add that back in, now you just have the 2 females. So that's just the match stage, right? Doing filters by a category, such as a person's gender, filters by, keywords that the user can search by, filter by numeric values like a person's age, and doing the pipeline with the match. The next couple of things, though, if we kind of go back to the notes, what else do we typically do? Well, we're going to do these stages. We're going to do match. We're going to sort the data. We're also going to do a skip and a limit to kind of enable paging. And this will, the skip and the limit to enable paging will be once we insert that front end to have like a paging control. So a sort is what we're going to do next. So here's our match. What we'll do is we'll set kind of a default sort. So by default, let's sort by, I don't know. Let's go to our data. Sort by last name. Sure, sort by last name. So last name : 1. Last name : 1. And then we'll add another object, $sort, passing in the sort object, save. So here's kind of a default sort. Of course, we're going to allow the user to modify the default sort. But if I kind of go back to Postman, I uncheck a couple of these requirements. We get B before H, before P. So our sort is working by last name. And what we can do is accept, same way, from the query object. We're going to accept a variable called sort by. Sort by. And we'll do a switch. It's probably been a while since you've done a switch, but just a fancy if, else if. In case of age, case age colon. Oh, come on. Then we modify our sort. We say sort equals age : 1, semicolon break, And we can change this, right? But the idea is we're going to pass in a sort by variable. We're going to switch on that variable, kind of have a default sort by last name. And then if they say, hey, if they change it, we're going to sort by the age. Then we change our sort object to age:1, which is no longer by sorting by last name. So let's go over here and let's do sort by age. And you can see 10, 13, 18, 36, right? 100. Which again, now we have our query string up here passing data from the front end to the back end. Then you got to decide what else you might want to sort by, right? So we're kind of sorting by last name. We're sorting by age. Maybe you want to sort by email, right? So if you want to sort by email, you could do case email sort equals email1 break. And if you change that up to sort by email, then you get A, B, D, so on and so forth. Right. And finally, the last two are skip and limit. Skip and limit together provide paging, and so we're not really going to do a whole lot with these right now, except we could test it to make sure it works. But when we actually build out our front end, so up here we'll also kind of say skip and limit. And after our sort by, we'll set the page number. Now, I put the wrong, this is page size and page limit. So, we're going to parse it into an int page number. This is going to say, hey, page number 2, right? So like at the first, if you're doing 5 records per page, we start with page number 2 would be like 10 through 15. So page number parseInt or page 1. And so if a page number is sent in, then you'll set the page number equal to that converted to an int. But if it can't be converted to an int, it's not sent in, it's going to set the page number to 1. And then this page size or kind of a default 5 records per page. And then we'll set the limit equal to the page size, and I'll have to explain this line of code. Const skip page number -1. The reason for the -1 is that in programming, we obviously count from 0, but on the front end, the user doesn't see page number 0. So if you say, uh, page number 1, really we're not skipping any, right? So 1 minus 1 would be 0, kind of thing. The idea is you have to take off the 1 because the end users don't start their count at 0. And so how many records do we need to skip, and then how many records do you show, or your skip and limit? Again, these two controls come together to do the pager control. $, skip is how many records to skip from that variable there, and how many records to limit. So match points at an object, sort points at an object, skip just points at a number, how many records to skip, limit also points at a number, colon. Okay, so if I kind of get rid of all my filters, page number is not defined. This needs to be page number. Now, if I send in a page number 1, let's see here. It's going to be the same thing about page number not defined. Let me take a look at this error. Okay, I just had to save my code. I did not make any changes. The last change that I made, for whatever reason, I don't know, was calling this the wrong thing. The page number and page size, right, are the two variables out of here. And I can set page number 1. Otherwise, that query still works because it says, hey, either you can parse the number that's sent or change it to 1. Same thing with page size. So kind of looking at this, we're getting, what are we getting? We're getting a page size of 1 and a page number of 1 and a page size of 5. So 1, 2, 3, 4, 5 records. So we're limiting ourselves to 5 records. And if I change this to page number 2 in Postman, page number 2, we're getting different records back. Page number 3, page number 4. Each time getting 5 records. Of course, if you want to change the page size, and maybe you want to change this to get 10 records back. And so what's really nice about this pipeline is it's very flexible. You can send in all sorts of data and search in all sorts of ways, sort in different kinds of ways, and get different paging results back. Okay, now this is pretty much what you'll need for the lab, right? Is really the theory, of course, and everything that we covered theory-wise today, but a lot of the code that you'll need is going to be very similar to what you see in this route. There you can see the debug, the pipeline that we kind of sent in. Skipping 30 records, limit of 10, skipping 15, limit of 5. Yeah. So that is what we'll need for the labs. And, if there's one thing you could do, you could extract this database logic into the database module, right? And send over a pipeline and run this cursor in the database tier, and then send that data back to the route tier. And so that, that could be the next step to kind of clean this up and kind of extract your database logic out of the route and kind of keep it in its own module. But this is what we need for now.